Lesson 2.9, weighted averages. In this lesson, we will not only solve mixture problems, uniform motion problems, and maybe otherwise called travel problems. You might be able to think of it a little bit better that way. I really do want to focus on mixture problems, though, because I think that you might face those a little bit more than the others. So you need to have your study guide 2.9 pulled up on your screen, and that would be the first page. That is 55, and we will do problems from that study guide to show you how to do it. I feel like me telling you things, it's just going to go in one ear and out the other, because I really think on these the best way to learn them is just see them done, practice a little bit, and then we'll practice a little bit more next week. To solve every one of these problems, you will need to use a table. They're not exactly all the same, but they're similar. Okay, so we're going to start with study guide and number 1. So I am going to pull it up and read it so that we see what the problem is. So study guide number 1. Okay, here we go. Number 1 says this: how many grams of sugar must be added to 60 grams of a solution that is 32% sugar to obtain a solution that's 50% sugar? Okay, when you're doing these problems, you really need to go through and pick out the important things. So we want to know how many grams of sugar. You're going to add it to 60 grams of a solution that's 32%. You want to obtain a solution that's 50%. All of those things are very important to be able to fill in to our chart. Okay, now I'm going to go back. You guys keep that problem up on your screen, and I'm going to show you what you would do with that. Okay, so when the problem states that it has sugar or anything like that, orange juice or anything, it's 100% of what they're talking about. It's not a solution that's a partial percentage. When it talks about a particular thing like sugar, under the percent column, it is definitely 100%. So you should fill that in. That's 100%. How many grams of sugar? So 100% because it's sugar. How many grams? Well, that's the question we want to answer. So under amount with sugar, we're going to just put in G, because it says how many grams. We don't know how many grams of sugar, but we know it's 100% of sugar. As you do these problems, between these two, you multiply to get the total. So 100% times G, well, don't use 100%, use the decimal equivalent to that. How do you change 100% to a decimal equivalent? What would it be? 1. So I'm just going to put 1G just for the sheer fact that you understand that it was 100% or 1. Okay, normally I don't write the 1, but in this case I'm going to. All right. How many grams of sugar must be added to 60 grams of a solution that's 32%? That tells me the next two things I'm going to fill in. The amount of the 32% solution is how much? 60. So under that amount by 32%, it says I'm adding 60 grams. And it is 32%. We already knew that because it's listed over there on the left. So as I multiply and equal, this part would be 0.32 times 60. Don't go ahead and multiply that out. Just write that. Now here's the mixture. The mixture that we want to obtain is 50%. Well, we know the percentage then. It doesn't come right out and say the amount though. But I'm going to tell you a secret. When you're doing these mixture problems, it's basically the top row plus the next row, and it equals that row. So if I added the amounts together from the 100% sugar and the 32% solution, how much would be in that mixture? No. How much sugar is there? What's it say? What did we write? Not over here in the amount column. How much sugar? 60 plus G, or G plus 60, let's say. So we don't know how much it's going to make, but we know it's going to be G plus 60. And if we're multiplying across, then it's 50%, 0.5, times the quantity, G plus 60. Once you fill every slot in, you should be ready to write your equation. Now, you know what I said right over here? How you take the top one plus the bottom one? Oh, no. I'm sorry. The top one plus the middle one, it equals the bottom, right? That's exactly what you do over here. So I'm going to take 1G, which we know is really just G, plus 0.32 times 60, and that's going to equal 0.5 times G plus 60. And at this point, then, you're ready to solve the problem. So I've gone ahead and found some of these numbers because I don't really want to focus on the actual calculating in here. You're going to have a calculator. That's fine. I am more concerned about us being able to fill in the tables and writing the equation. Once you get that, honestly, it should be the easy part coming up. So I'm going to say G plus 19.2 equals, and then you would distribute 0.5 G plus 30. Okay, bring my variables together. Well, my smallest one is 0.5 G, so minus 0.5 G from each side would give me positive 0.5 G plus 19.2. Those cancel out and I get 30. Subtract 19.2. .5 G equals 10.8. Divide by 0.5. And G equals 21.6, and it is grams. So these will all be labeled something. 21.6 grams. So you always go back and double check. It says how many grams of sugar. Make sure it doesn't say how many of each thing or something like that. Of course, they already told us that the 32% was 60, so we already knew that. But in this one, it was asking how many grams of sugar. So 21.6 grams. Okay, we have done one. What do you think? Lots of stuff to it, right? Yeah. Okay. Really important. Did everybody get the red written down so far? Okay, we're going to go on to the next one then. So if I look and see, I'm going to go ahead and do now another mixture problem, a little bit better. I think most of the time kids like these a little bit better. Let's go to, again, you should have it on your study guide, the first page. So here's the problem. It says, the Quick Mart has two kinds of nuts. Pecans sell for $1.55 per pound, and walnuts sell for $1.95 per pound. How many pounds of walnuts must be added to 15 pounds of pecans to make a mixture that sells for $1.75 per pound? So again, when you guys are looking at these, you really need to point out the important information, the stuff that you're going to use. You need to make sure you know pecans, $1.55 per pound, walnuts, $1.95 per pound. We're asking about how many walnuts, that's what we're searching for, using 15 pounds of pecans. The mixture, we want it to sell for $1.75. So we got to figure out how much of each so that it's really a $1.75 mixture. Okay, so let's get back to the notes. You guys keep your page up there so you're looking at it and you know what the things are. All right, so I've got the table already set up. This time it's going to be price, the pounds, and the total for each thing. But again, it's a mixture problem. So when it's all said and done, we're going to be taking the pecans amount, adding to the walnuts amount, and that's going to equal the mixture amount. So you multiply across price times pound to get your total, but to get the equation, you take the top line plus the second line, and it should equal the third line. That's the way mixture problems always work. Top line plus second line equals mixture line. All right, so we're talking about this. Let's look at to try to fill some of this in. Pecans, how much are they per pound? What's the price of pecans? $1.55. What's the price of the walnuts? $1.95. What do we want the mixture price to be? $1.75. Look at that. That was easy to fill in that column. So good, that's done. That's good. Now the pounds. It says how many pounds of walnuts must be added to 15 pounds of pecans to make a mixture that blah blah blah. So what am I going to fill in for pounds with the pecans? What? 15 pounds of pecans. What about how many pounds of walnuts? We don't know, right? So let's go W. How about that? So then, similar to before, how many pounds will be in the mixture? W plus 15. We good with that? Okay, now let's figure the total column. So for the pecans, you would take $1.55 times 15. For the walnuts, $1.95 times W. The mixture, $1.75 times the quantity, W plus 15. Okay, you think you could write the equation? What's the first thing I should put, do you think? Josh? $1.55 times 15 plus what, Megan? $1.95 W equals what?
175 times quantity 15 plus 10.
Yeah. Or W plus 15. Okay, so do you see how that's the same mixture? Top line plus second line equals third line. So that's not so bad. Once you get that table filled in, you should be good to go. All right, so again, I kind of cheated ahead here. I've got 23.25 plus $1.95 W. And then I distribute $1.75 W plus $26.25. Bring my variables together. So the smaller one, I subtract the $1.75 W from each side. Always do your variable first. So $23.25 plus 20 cents W equals $26.25. Okay, subtract my $23.25. I get 20 cents W equals $3. divide by 20 cents. W equals 15, and what does that really stand for? 15 what? Pounds. And pounds of? Yeah, why not say that? Pounds of walnuts. Did we answer the question? Look back and see what the question really asked for. Yes, how many pounds of walnuts? Okay, so we've gotten